Hello everyone. So today we are going to try to make a ADAS system and anti-collision system for automotive vehicle or EV. So, as we all know that for the autonomous vehicle or for the autonomous driving or for the driving assistance system, anti-collision system is very important. And so today we are going to make a anti-collision system for that, and later we will design a ADAS system, and then we will take another session on the same thing, and where we will make a sort of advanced, people recognition system, and a speed controlling system of vehicle, and we will also integrate the same our ADS system with EV motors and these controllers to control this. But we will do it later in the next session. So today we are going to just make a smart vehicle anti-collision system using the LiDAR. So so that you can mount the LiDAR like this. Let me show you. You can mount the LiDAR. You can mount the LiDAR on the vehicle like this, and scan its surrounding, and then you will get the alert and data of map record of vehicle around like this, and you will get alert regarding something is colliding with the vehicle, or it is getting so close, so you can alert you to speed down the vehicle like this. So this is what we are going to make. So this is the very first session. So in this session we simply learn about the ladder, and then we connect the ladder with the PC and scan the surrounding. Then we connect the ladder with the SBC board and design an anti-collision system, and then we make a ADS system that shows you live graph scanned by the ladder, and alert you when vehicle is about to collide, or when some car is so close, and it will alert before the accident, and you can also design it to implement for the auto braking system. And later we will taking forward this session to the next session, where we will design a system, and able to integrate the system with these hub motors. Let me show you. With these hub motors, for the EV, and this controller, so that we can and control these hub motors with this controller for the EV, and make auto braking system for those. But we will do it this later. So let me start the things that we need for this project. So for the simple ADS and anti-collision system, what we need a one board that you can use the RPI board like this, or you can use any other board like NVIDIA Jetson, or any another automotive grade board if you're deploying on the uh, 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 automobile or EV. And then you need a ladder. You can use any kind of ladder. We are using this ladder. We are using this YD X2 ladder. But this ladder, you can use any other ladder. Like you can use the RPI ladder. You can use the either YD2 ladder like this, or you can use RPI ladder, or you can also use the Velodyne ladder. So whatever the ladder that suits you, that's for you can use it. Here we are just making a simple prototype of our ADS system. So I'm using the YD-X2 ladder. This is the cheapest ladder that I got, and it came around 5 to 6 thousand. But you can use the RPI ladder that came around 7 to 8 thousand. You can also use Velodyne automotive grade ladder that came around 25 to 30,000, and any other kind of ladder. So first let me show you how this ladder works. So actually all these ladder came in many different technology with many different functions. But here we are using very simple one ladder, the YD-X2 ladder. Here we are using very simple YD-X2 ladder, or you can also use the RPI ladder. So whatever the ladder you are using, you just need to check that ladder is compatible with the board you are using. It is compatible with either NVIDIA Jetson board or RPI board that we are using. So for checking the library and module available for the ladder, you can simply search here. Like I am using YD-X2 ladder, so I search here YD ladder, and I will able to get the ladder. If you are using the RPI ladder, then you can search the RPI ladder Python library RPI ladder, and if you will get the library for the RPI LiDAR. So it's depend on the LiDAR that you are using. So LiDAR came in very different formats. Some are like this. Some are like this. That this is a 360-degree LiDAR. So for the current design that we are using for the anti-collision system, we are using the 360-degree LiDAR. So what do this LiDAR? These LiDAR have a motor like this. You can see here. These LiDAR have the motor like this, and one controller that give you the output, and it have the a set of a laser transmitter and receiver. This is the laser transmitter and receiver. So this has laser transmitter and receiver. So this move rotate like this, and it scans the surrounding and give you the output according to that. So so its range is 360 degree. There are some other lidar that is not moving. They are solid state lidar. So they can only sense from the front angle, either front angle, and they have sensing range around 180 degree to 250 degree around itself. So it's depend on the you how you are going to which kind of lidar you are going to use, but it's better to use the 360-degree lidar because it give you the is scan the surrounding to the 360-degree angle all around your vehicle. So you can make a protection system around all your around the vehicle. You can scan the all the surroundings of vehicle, and if any vehicle came so close to your vehicle to that might cause the accident, it will alert you, and you can see that data in your ADAS system, and it will assist you in parking and many other things as well, and it will also make an autonomous system for that. So we are using this. So for using any kind of ladder, there are two things is important. When you are using this kind of ladder, then the mounting is very important. So where you are going to mount the ladder like this, you can mount the ladder either on the back side or on the middle side or on the front side of the car. So while you are mounting in the ladder, the car when you run the car, it vibrates. So while mounting the ladder on the top of the car, you must need to think about vibration, the stabilizing the vibration, because if the ladder vibrate, then the data points will get the wrong data points, and your ADS system don't work that perfect. So you can either use stabilization pads, the rubber pads, or you can a foam kind of thing to attach the ladder to eliminate the vibration. So you need to think about that. And next thing, while mounting a ladder, you need to think about the angle. So here you can see, when you buy the ladder, they will give you the data sheet. So like any ladder, you are using this ladder, or you are using the RPI ladder, they will give you the data sheet. So if you have to check the data sheet. In the data sheet, they will show you which is the angle 0 point. This is very important point by mounting the ladder. So if you are using a ladder, you need to know the angle 0 point. So it is provided in your data sheet. So as in our ladder, this is our 0 point, angle 0 point, this thing. So here my ladder, if I mount the ladder like this, if I mount the ladder like this from the front side of the car, then this if ladder move from this side to this 180 degrees cover, and this 0 to 90 degrees cover, and then 250 to 360 degree got covered. So but we need to get the data of the 180 degree or 250 degree from the front side. So I have to mount the ladder like this here. So you need to you need to check this while mounting the ladder. Where is your angle 0? Where is the angle 0? So like this, my ladder is kind of a triangular ladder. So its angle 0 is like this. But some ladder is this, or some are like this. So it's depend on the ladder what you are using, and they will give you the data set. So you have to check the data set. Where is the angle 0 point, and mount the ladder according to that. So suppose that I want to check the scan the angle of car front. This is suppose that this is my car, suppose that, and I want to check scan this side of the this 180 degree or 250 degree from this side. So I have to mount the ladder in such a way that our 0 to 250 degree or 180 degree came to the front side. So if I mount like this, if I mount like this from this side, like this. Then then we got 90 degree, and then to 50 to 360 degree. This is not the right way to mount the lidar. Then we have to move the lidar to this side like this, and we have to mount the lidar like this. So this thing you need to you need to check first what is your 0 degree angle side of your lidar, and how you can stabilizing the vibration of the vibration of the vehicle while your lidar is mounted, so that you don't get much wrong data points. uh, so these two things are important. So after this you need to check the range of the lidar. While selecting the lidar, you can check the range, and another thing that you can check is the FDA rating. So lidar use the laser wave, so some and you have to check the government policy and FDA rating of the lidar. So that this is FDA class 1 rated lidar, so I can use it in the public places mounted on our vehicle. Some lidars use class 2 lasers or something like that. By chance, the in that country, that government policy didn't allow that you need to think about those, and select the lidar wisely according to the FDA rating. Another one is the range. What is the field view? So as I have already told you, our lidar is 0 to 360 degree, so it can scan to 0 to 360 degree. And another thing you need to check is the baud rate of lidar. While using your lidar, what baud rate it is giving you. If it work on the USB serial port, then you need to check the baud rate of the lidar, so that you can get the data and connect your lidar with your system. So this is the baud rate of lidar. So while making this kind of any kind of this system, like anti-collision system or ADAS system using the lidar, you need to check the data sheet, and you have to extract the data points from the data sheet, whatever you need to you are in your project, like baud rate and the angle, 0 degree angle of your lidar, this thing. So this 0 degree angle, 0 degree position of your lidar. So you need to check all those things from your data sheet. So like if I use the RPI lidar, then it will give you the 0 point and all those details here. And while when you use any kind of ladder, they will give you the data sheet as well as software and SDK for using the ladder, like Python SDK or other language SDK, so that you can get the ladder and you used it and program it according to your use. So like I am using the BID ladder, so I have downloaded its SDK. So let's check the ladder, our ladder is working or not. So here is our lidar viewer. So I am using the YD lidar, so I downloaded it according to that. So I am going to connect the lidar. So first I need to connect the lidar. Let me connect it. COM port. So here is the lidar version. What I am my lidar version is X2, so I am selecting this X2. And it depends on the lidar that and the company that you are using. If you are using any other company, their lidar viewers and their peripherals will be different, so you need to check according to that. Our lidar is X2, so I am using this one. So when I connect it, I can see the data points and the angle. So it is connecting. Yeah. So as you can see, this is the lidar data points, and this is how it is scanning. And let me show you the video of this. So as you can see, this lidar is moving and scanning my environment. See, so when I put it up, there is less obstacle, and it is scanning my room. This is how my room look like. So when I move the angle, this will also move according to that, like this. And when I put the hand around this, as you can see, the data point will show according to that. And you can get the distance by putting putting the hand to that product data point. Like here you see it says the distance and the angle at that particular instant of time. So this is the angle and this is the distance. It is showing like this. So this is it. So now we have checked the LiDAR. Our LiDAR is working, and it is working correctly, and we are able to see the data points. Now let's make our anti-collision system and ADAS system for our thing. So let's disconnect the LiDAR from our laptop, and whatever the development board SBC you have choose to use. Here I have choose to use the RPI board. So I am going to connect this to the RPI board, this YD LiDAR to the RPI board. If you are using another board like NVIDIA Jetson, and you can connect to the USB of that board. So it's depend on you. I am using the RPI board. You can use the NVIDIA Jetson or any other automotive grade if you are actually deploying that. Here we are trying to give you this simple idea to make the project how you can make a simple anti-collision system. So I am using RPI board. You replace it with any other automotive grade development board, and this ladder is work for is okay for the automotive. So after that, we will open the BNC viewer, and this is my RPI window, as you can see. So according to your ladder, you need to download the SDK module, the library for the ladder. So you can search in the Google. So suppose that I am using the YD ladder, so I can search here YD ladder X2 Python library. Or you can simply search here as well. So let's search in the Google YD ladder X2 Python library. So I can get the Python library here to read the data set. So you need to just copy this and install the SDK. And in the data set, they will also tell you where the SDK is, how you can download the SDK, and it's depend on the kind of LiDAR. If you're using RPI LiDAR, then give you they will give you the software like this. This is the RPI LiDAR software. You can use it to scan the document, and you can download the SDK and software according to their data sheet. So I am using YD ladder. So I have just copied, and then you have to open the terminal and install the drivers for that. So I've already installed the drivers. I'm just showing you how I am going to clone the clone the library for using that ladder. So and then I have to paste the and it will clone it. So this I have already downloaded the uh, the LiDAR SDK folder, as you can see, and I already installed the library. So I'm not going to do it, but it's depend on your LiDAR. Whatever the LiDAR you will about, they will give you the user manual with the data set. You can check that and download the SDK and Python SDK and Python library for that. So here is our Python library, and so as So here is the LiDAR x2.py. This is our Python library. So we need to do some changes to extract the data from this. So this is the code for connecting the LiDAR and extracting the data. So whenever you connect with the LiDAR with the RPI board, you need to first define the port number. What is the port number? Serial port number. Here I have connected the RPI board ladder, and our serial port name is this. So you can check this. First need to check the serial port number. To check that, you can simply type the USB, and it will give you all the connected port on the RPI port. So here our serial port is the this one, and then to get the angle and the distance, we need to make a uh, uh, we need to make the code, and then we will print that whatever the angle at that stand of that stand, and what is the distance scanned by the lidar. This lidar in support that is at 0 degree. So whatever the distance scanned by the lidar, whatever the distance that is reflected distance of the laser, it will show you this. So we will check the scan angle and the distance. When I run this code, it will show you the angle and distance of that scanned by the lidar at that instant of time. Say it will giving the angle and distance. So this is now giving the angle and distance. So suppose that we are going to make a vehicle collision system. For the vehicle collision system, suppose that I have mounted the ladder and I want to scan. I want that no one came to 230 meters or 300 meters in front of my car, and if someone came within that range, that and going to colliding my car or then either it will automatically do the braking system or alert us. For that, we can check the angle. So we will add a if condition. So if angle each 220 degree, if you want to that no vehicle came close to the car, that beyond this to the 360 degree, that you can keep this to the 360 degree. But here we are just using the front side. So front side from 0 to 180 degree, this side of the vehicle, this side, this front side. So if any car came closer to the 220 millimeter came closer within this range, then I want the my system my ADAS system to alert me and do auto braking system, or automatically slow out the speed, or just alert me. Whatever the function you want to set, you can set in the code. So here we are just setting for the alert system. So I make a if condition and make this angle. If the angle is 220 degree, then it is it is smaller than 220 degree. And uh, and if the distance is below 300 millimeter from scan distance is 300 millimeter, then it will alert that distance. You have to slow down the car and or do press the brake. So when I run this code, it will alert me whenever any vehicle come in front of it. So this is the system. So as you can see, it is showing angle and distance. And when I move the hand close to the ladder like this, you can see 1 minute like this, it is showing slow down the vehicle. See, slow down the vehicle, this message. So I am showing you this. I have disconnected the RPI by chance. So sorry for that. I have removed the RPI USB. We have to reconnect it. So this is how it works. But this is not just only alerting us. So if you want to visualize what happening around it, if you want to see the scan data around your LiDAR, then you need to use a matplot code, and you need to plot the graph that is scanned by the LiDAR. So we are going to do it right now. So first, let's connect it. So as you can see, it is scanning around itself and showing me the distance. So when I bring the hand near it, it will say me slow down the vehicle. And if you want to set the function, like when it scan the somewhat vehicle going so close to it, it do automatically braking. Then you can use any of this GPIO pin on the RPI board, and control a actuator or braking system using this, so that when any vehicle came around very close to your car, it will automatically do brake and to avoid the accident. So this is please slow down the speed. See the message. When I put the hand close to the ladder, below that range that I have set in the code here, in the code, in this code, it will show me the message of please slow down the vehicle. And if you want some alert, like it will make some noise or say something, then you can add ESP or something kind of buzzer and attach to the GPIO pin, and then implement some function in the code. So it's on you. So what you first need to do is to check the baud rate, and then then the USB, then you need to download the uh, 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 download the SDK of whatever the LiDAR you are using, and then you need to put that in the code on to whatever the serial port you are connected the LiDAR to, and then you need to check the speed and distance. So if you are using if you are if you want to scan the only check the only front side to 220 degree from the vehicle, so you can set that, and then you can check the distance, whatever the distance, threshold distance, that safe distance that you want to keep for your vehicle. You can set that, and then you can set the function whatever you want to add. Like if you want to add the auto braking system, you can simply pull any of the GPIO pin and connect it to the actuator to automatically make the brake and avoid the accident of this car. But this is only anti-collision system. It only giving a lot now. So I want to visualize this. So for visualizing, you can use the matplot library. For that, you need to install the matplot. So for that, you need to use the matplot. So you have to install the NumPy and the matplot library first to get to visualize the data. Matplot is used for plotting the graph in real time, and NumPy used to calculating the do the numerical calculation. And then we need to define the angles all around itself, the circular angle that is 0, 25, 90 degrees. So we can able to visualize at what angle, what is the at what angle the ladder is a scan data point is there. And then after that, we need to check the variable distance and the angle, and the uh, uh, and the set after that, we, we will make a function, so that matplot will show 1 minute. So the matplot will show that uh, those plotting to us like this like this. So it will scan and give the plotting like this. So you need to set those things in the code, and when you run the code, it will plot you the data. It will start plotting the data around the ladder. So that's all for today. We can If you have any doubt, you can ask me. So this is how you can make the whole project, whole system, each published on electronics for you this week. And this is the very first session. We will further connect it and control it, control connect this whole system with this hub motor of EV and with this controller of EV, and we will control the EV motor controller and connect the whole ADAS system, whole anti-collision system with this motor and controller, and we will control. We will show you how you can control the EV vehicle and do the auto braking system when some vehicle came so close to your vehicle and it is about to collide your vehicle or do the accident. So in next session we will talk about that. So that's all for today. If you have any doubt, you can ask me. So this is how it will show you the data around the ladder, the scan data in real time. So if you have any doubt, you can ask me any question. This is only first question. This is only first session. Here we have checked how we can connect the ladder and get the data. How we can make an anti-collision system that will give you the alert. In next session, we will control this hub motor of the EV with this controller, and then we will make an auto braking system. And so whenever the LiDAR detects some vehicle came so close to it, then it will stop this hub motor and we will do the auto braking system. And we will also talk how you can attach the same thing on your any other vehicle by using actuator, pneumatic actuator, and or hydraulic braking system, how you can implement this whole system to the hydraulic braking system on the actual vehicle. So we will talk about this later, and we will be going to publish whole series on the electronics for you. So this is first series will be came on the Monday, and next we will show you the next series uh, deployment of the vehicle or EV in the next part of the same series on the electronics for you. So keep checking there. We will going to publish it. So if you have any doubt, you can ask me. No doubt, no questions. So thank you everyone. We will meet in the next session and we will talk about how you can implement this system on the EVs. Thank you. And how you can control the actuator. And we will also make a more complex system like detection of human person and detection of a speed of incoming car using the radars. We will and make a whole ADAS system and the dashboard for that. This is just a starting. This is just first part of that. So we will meet in the next session as well with the more complex system on that. So thank you.